Hello, my name is Michael Smith, and today we're going to explain why and how the common technique of adding noise into your coordinate system works. So this is a really common technique. You'll see it in things like the cracks texture that I did or the wood texture that I did. Anytime you've got basically a geometric procedural texture and you want it to look a little bit more organic, what you'll do is go ahead and take noise texture and mix it into the input coordinate system. And so I'll talk about how that works in this video. So to start with, I'm going to demonstrate how this technique works. So the way that it works is you take something like this texture. So I've set this up so we can move quickly. I've got just the generated coordinate system. I've got the checker texture. The output of the checker texture is just going into the color, and I get this nice checker pattern. And I want to break it up a bit. So a really common technique, we'll do it on this guy, is you take exactly the same thing, and now you add texture, noise texture. That looks like this pane on the left-hand side. So this is going to give us a nice gentle gradient to a noisy texture. And what we do is we take that and we do add color mix RGB. And then we add our noise texture into our generated texture and mix the two. And if we go all the way here, we get this nice marbled pattern. If we go all the way here, we get just our straight lines. And although it's not going to work in this case, and I'll explain why that is in a bit, if we do a little bit, we should get a nice wavy pattern. In this case, instead of getting a nice little wavy pattern, we immediately go to this weird marbled pattern and then sort of transition into the final thing. So we'll explain why that is as we explain why this technique works in the first place. So to explain what's going on here, I've drawn a couple pictures for you, and we'll explain what these are. So at the top, I've got this cube. I've got a cube cut along the diagonal, and I've got a plane. And all three of these, all I've done is taken the generated coordinates and put them into the color. If you remember from the basic coordinates tutorial for procedural textures, the way that the generated coordinates work is we take the bounding box of the object, and then we ramp up along x, y going backwards, and z going up from 0 to 1 along the edge of the bounding box. So for a cube, this is a 2 by 2 by 2 cube. What it's doing is going from 0 to 1x, 0 to 1y along this direction, and then 0 to 1z along this direction. And we can see that in the colors, because when we take those coordinates x, y, z, they map to red, green, blue, as you can see in the top right corner here. And if we cut away the diagonal, what happens is right along this diagonal, we're going from 0, 0, 0 to 1, 1, 1, and effectively getting the grayscale. So if you go from this bottom corner to that top corner, you're getting a grayscale. The final one is the plane. So the plane, if you just create it by default and plug in the generated coordinates, it's going from x0 to 1, y0 to 1, and actually z.5. So it puts it in the middle of a bounding box that extends out from the plane. I don't entirely know why it still creates a whole bounding box. You can see this if you go to Object Properties, and under here, Viewport Display, and then click on the texture space. So there you go. But anyway, that's what it does. And so what you're seeing here is instead of this being a straight red or a straight yellow, we've got blue mixed in. Okay, the second set of objects I have here are the checker objects. So you can see on the checker object, what it does is in 3 dimensions, it's actually alternating cubes of white and black. If we cut away a cross section like this, what we get is just black on the bottom and white on the top. And the reason we get this layer cake is because on the top, it's just giving you a cross cut of this white cube and that white cube. And on the bottom, it's giving you a cross cut of this black cube and that black cube. And if we take a plane, we get a nice checker texture. Now remember, because this will become important later, that by default where this plane is at 0.5z. So it's right on the boundary of this bottom layer and this top layer. And so we're getting the bottom layer, we're getting this black cube, that white cube, that black cube, and the back white cube. But if we moved it up a tiny little bit, we would get the exact opposite, this top layer. Now what I've done to explain how this works is I've taken this plane and I've flipped them so that instead of seeing, instead of having to sort of do this, we can see them straight on. And so in this case, I've drawn our coordinates again. Y goes up, y goes up this way, x goes left to right. And I've now taken this same texture and put it here, and now added the noise texture. And then in this guy, as we saw earlier, we're mixing the two. So now the question is, when we mix them, what are we actually getting here? So To explain what's going on here in this mixed texture, we're going to start with what's going on with this noise texture. So this noise texture, we take in the generated coordinate. So as we move through this coordinate system, x and y, what we're getting out is a value that's between 0 and 1. And that's getting mapped to a value that's between 0, 0, 0. Fix my 0 there. And 1, 1, 1. So when we pass this in as a color, what it does is it takes the 0 value and interprets it as red, green, blue, all 0. And the 1 value interprets it as 1, 1, 1, red, green, blue. And then what we're doing is just transitioning between those two gradually. And so effectively, if we pass that in as an input to the coordinate system that's generating this checker, what we're doing is moving from along this axis, right? Because this is 0.000 and 111, and we're moving back and forth just along this diagonal. So when we look at this texture, what's happening is we're no longer taking in this x and y, right? That's going into the noise. The noise is putting out this 0 to 1. That 0 to 1 is only mapping from 0, 0, 0 to 1, 1, 1. So along this diagonal. And what we're getting here is for each point, it's looking at the noise, mapping it along this diagonal, and then printing out the color. And because along this diagonal, at half point, we go from black to white, we get this kind of cow pattern where some of them are going to be black, all the ones that basically map below 0.5, this half point, right? So 0.5, 0.5, 0.5, and then white when it's above 0.5, 0.5, 0.5. So we can replicate this without using this texture as input coordinate to another texture. We can demonstrate this by taking the noise texture and just saying, okay, well, if we know that this is going along this line, effectively all we're saying is make it white when it's above 0.5, 0.5, 0.5, and black when it's below 0.5, 0.5, 0.5. And so we're going to go to add, converter, math, and we're going to go to greater than. And what this does is it sets the output to 1 when it's greater than 0.5. The input is greater than 0.5. It sets the value to 0 when the input is less than 0.5. And you can see that these two, this one that maps the noise texture as the input to the checker texture, and this one work exactly the same way. So this can now explain to us, I mentioned right at the beginning of the video, this weird functionality where for some reason when we put a little bit of this in, we immediately get this 4-quadrant look as opposed to just getting a little perturbation. And then we transition to now this full noise node. Why is that happening? In previous examples with like waves where we were doing wood, we got a little bit of variation and then a lot. But here it seems like we get a lot of variation immediately. Well, now that you understand what's going on, hopefully this is pretty straightforward to answer. So if you want, pause the video, think about where this plane is and what mixing these coordinate systems is doing, and maybe you can answer that question for yourself. Okay, what's happening? Well, remember that this plane is actually sitting right on the boundary, the z boundary, 0.5, between this lower half and the upper half. And the result of that is that if you change the z value a tiny little bit up, black is going to flip to white and white is going to flip to black. And that's what's basically happening here. As we mix in the noise, what's happening is eventually we're just going along this diagonal. But where we're somewhere in the middle, we're still, in our XY position. We've maybe moved a little bit towards the diagonal, both in terms of moving along the Z axis and the X and Y axes. And the result is that anywhere where we move from the bottom 0.5 to the top 0.5, along here, we're going to get it to change immediately. So instead of getting little changes, we get big changes. The way to adjust that, if we shift right-click here, is we just need to move this texture so that it's not right on 0.5 in Z. So we're going to add converter vector math, and we're going to take the Z value and we're going to tweak it very slightly. So we're no longer sitting right on the boundary. And if we do that, this looks a bit more like what you would expect, because instead of getting that dramatic change where we go over this boundary into a completely opposite color scheme, you're now transitioning gradually along Z. And then we get the flip, and then it fully goes over to the new texture. Of course, these two don't map anymore because now we're along a different Z value because I've added in minus 0.4 here. But the principle's the same. So if you wanted to understand why adding in noise texture does what it does and makes these nice wavy patterns and maybe sometimes doesn't behave the way you're expecting, hopefully this clarifies the magic that's going on and you learned something. Thanks.